In this video, I want to talk about how we can return multiple types from single functions in F#. So when we write code, sometimes we have different parts of our execution where we want to return potentially different types. In C#, we could handle this by defining sort of a common anonymous type and then returning that. But in F#, it's a little bit more tricky because anonymous types are not really supported. So I'm going to show you a couple of examples now. The first one illustrating the problem and the second one giving you one way which you can solve it. So we're going to start by defining a couple of types for this. The first one is going to be a Vespa, and we are going to say that this is a record and it needs to have some amount of horsepower. Let's do it like that. And then the other type that we're going to define is going to be a motorcycle. And this one will also have a number of horsepower, but it will, in addition to that, have a top speed. And we'll let the top speed be a float, like that. Okay. What I want to define now is a function, a simple function called buy. And the idea is we would go to a dealership with some money and we would want to buy a motorcycle. The idea here is if your money is less than 10,000, you're not going to be able to afford a motorcycle. So in that case, you're going to get a Vespa. So we would then say Vespa, actually let's do this. Let Vespa of type Vespa, to make it clear, equals, and then we'll implement this record. Let's say it has 10 horsepower, like that. And I would want to return Vespa, like that. Otherwise, if you have more money than 10,000, then what you're going to do is you're going to get a motorcycle. So we're going to say let motorcycle equals, or of type motorcycle as well, equals a record, the amount of horsepower, let's say that's 100 in this case, and in addition to that we're going to have the top speed. Let's make that 200. All right, and then I would want to return this like that. Let me try and define this now and I'll show you what happens. So as you can see, we get an error, and we're saying that all branches of an if expression must return values implicitly convertible to the type of the first branch. And if you look here, we have now a motorcycle that we're trying to return and a Vespa we're trying to return. These are two different types, and we cannot have this execution evaluate to one or the other. There are ways around this. The most common way to address problems like this or these kinds of situations would be to make use of discriminated unions. So I'm sure we're familiar with those by now. You would define that in the following way. So you could say two-wheeler is going to be a type, and then in here you would say Vespa of Vespa, like that, and then motorcycle of motorcycle. Okay, so now we have one common type here, and what we can do is we can convert what we now created here into an instance of that type, and we would do that by just wrapping these in the corresponding types like this. Okay, if I evaluate this now, I get an error because I've misspelled. The part I misspelled is up here. So Vespa goes to big Vespa. All right, you can see now that the compilation works. So technically speaking, we can create this function that's going to now return an instance of two-wheeler like this. And if we wanted to call this function and define some behavior, what we can do is a simple match statement. So match by, and then let's say we have 1,000 with, and then we'll define two cases here. So first one, we'll catch a Vespa, and then we'll print something here. Let's just print fn got a Vespa. Let's actually print the structure as well. Okay. And then for the next one, we'll define a motorcycle here. And in that case, let me just copy over what we had here. All right, but we got a motorcycle instead. Okay, so we can do some matching behavior on this in the following way, and then it will catch the appropriate type that we return. So let me execute everything again. You can see now that we got a Vespa with 10 horsepower. And if I increase the amount of money that I have going to the dealership, what you're going to see is we get a motorcycle instead. So if I do that, you can see got a motorcycle. And horsepower 100, top speed 200. Cool. So what's the problem? The problem is that whenever we define a function like this, we would necessarily need to define this type. And that might be fine if we're referring to this type a lot of times, if there's a lot of references in the code to this kind of type. But if we're only doing this once, then having a lot of types that you need to define like this in different parts of the code will become quite tedious, and it will clog down your code and make it harder to read. One way around the fact that we cannot construct anonymous types is the fact that we can make use of the choice type in F#. So I'm going to modify this code slightly now. I'm going to copy all this over to my next script here, and we're going to make some modifications. Now, I want to remove, first and foremost, this thing right here. And I want to now make use of what's called the choice type in F#. I'm going to say what this function now returns is a choice. And then we need to provide two types here. These types correspond to the types that we allow to return from. So it would be Vespa and it would be motorcycle. Okay. Now we would still define this Vespa in the same way as before, but instead of wrapping it in the constructor from before, what we will write here is choice 1 of 2 Vespa. Okay. This is a predefined part of this choice type, and it says we define now the first of these two types, which corresponds to the type Vespa, and then we feed our Vespa in there. Okay. For the second one, we would instead do choice 2 of 2, and we can see here in the type that choice 2 of 2 corresponds to a motorcycle. And then I will remove this constructor and just put the motorcycle in there. Okay. If I just run this first part here, we can see that this is going to compile. So we get no issue here. We still can't call it because we need to make a slight modification to what we see down here. But this part allows us to actually define multiple types inside of one of these functions without defining that type explicitly outside. Now you have to make use of these specific parameters here, and you have to make some modifications to how you treat these values. But in principle, this is a way around it. You can create up to 7 types here. So you can have multiple parts of your code that execute into different types, and you're not restricted to 2. But yeah, that's the way you can get around it. Now, what I would replace here, so in the implementation, we need to make a slight modification. So here, instead of Vespa, we would now have choice 1 of 2 as the type. And here we would have choice 2 of 2. Whoops. Here we would have choice 2 of 2. Okay. If I execute all this now, you can see that we got a motorcycle, right? And I can change this again to something smaller, and there we go. And I got a Vespa this time. Okay, so that's a way around having to define these types. It's not the most elegant solution because, well, you have to put these sort of types here that don't really correspond to the types of the parameters, so it looks a bit clunky. Also in the match statement here, I would prefer if there was some reference to the actual type that you have here, because this name, technically speaking, can be whatever. You don't need to call it Vespa here. You could call it like Lollipop, right? It's just the parameter. Well, it's just the fact that the parameter name needs to coincide here with here. It doesn't really matter. So this can be partially a source of confusion as well. But nevertheless, if you have these kinds of types that you find yourself defining all over the code, this is one way that you can circumvent that.